logarithmic functions. All right, so pay attention because this gets complicated really fast. All right, on the left-hand side here, log b y of x. That is what we call logarithmic form. And on the right-hand side, we have b to the x equals y. That's what we call exponential form. Now, in mathematics, we have operations that kind of undo each other, right? Addition undoes subtraction, and vice versa. Division undoes multiplication, and vice versa, right? Well, guess what? These undo each other. So if I want to get rid of an exponent, I could take the log of it. If I want to get rid of the log, just make it an exponent. You're going to have to remember that because we're going to be doing a lot of that. And when we get to it, I guarantee you the people talking right now are going to go, you don't know what you're talking about. You suck. You don't teach. Blah, 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 blah. It's your fault. All right. What? Yeah, well, first of all, we're going to switch back and forth, which is what we're going to do right now. But, like, if I wanted to get rid of this log base b, I would just make it an exponent of the base b. And we'll do some of that later on, okay? That's what I mean by undoing each other. All right, so, yes, lots of calculator in this. All right, so if we look at the form, I have log. The little b here is my base. So I have the word log. And then I have the little b that's kind of subscript of that. By the way, when you're writing log, you have to kind of put it as a subscript because if you put log b, it means something else. You have to put it underneath the log for it to be the base. Okay, b stands for base. Now, what does y always stand for? Well, y is the solution, right? So y is just our number. And then the x, our x is going to represent the exponent. Yes, we're going to talk about that in a little bit. No, although those are trig functions. It's okay, so exponential form. So let's look at our exponential form. What's b to the x? What's that called? In fact, what's any number called? Every number is a power, right? Every number is because there's a number 1 as an exponent. We just never write it down. So pretty much every number is a power. Okay, so we have b, which is our base, right? Raised to our x, which is our exponent, right? Oops. That's going to equal our y, which is our number. Okay, it's just a number. Solution. Okay, so we're going to go back and forth right now. We're going to go back and forth, if it's well, these are in log form, we're going to put them in exponential form. Okay, so number 1. I'm going to put my power first just because it's like that in the formula here. So what's my base in log? base x 32 equals 5? X. My base is x. What's my exponent? 5. Very good. What's that equal? 32. That's my solution or number, right? Y. Now, does anybody happen to know what x is? 2, right? 2 to the 5th is 32. That's important because in this next section, we're going to actually have to figure that out, okay? All right, number 2. What's my base? What's my exponent? And what's my Yes. Because what's my solution? What's my y? Okay? Any number raised to the 0 is 1. Okay. Do you guys see this?
Okay. Get the number.
Number 3. What's my base? Okay, what's my exponent? And what's my solution or y? Is 10 to the first 10? Beautiful. Perfect. Number 4. My base. What's my exponent? -1. What's my solution? 0.1. Is that true? What is 0.1 as a fraction? 1/10, right? Is 10 to the first 1/10? Yes, it is, because we have a negative exponent there. Remember, it's over 1. What do we do to get rid of negative exponents? We flip the fraction and make it positive. So, yes, 10 to the -1 is 1/10. It's going to be important in about 3 minutes. Okay, number 5. What's my base? That's right, 1/2. What's my exponent? What's my solution or y? Is 1/2 to the -1 equal to 2? Yes. Remember, it's a negative exponent. You have to flip it. Okay, number. No, and we'll get to that in a minute. No, yes and no. So we'll get to that in a few minutes. Okay. Now, this doesn't have an exponent, so what am I going to put there? X will work. Right? X, look at your log form. X goes there. Okay. Okay, so what's my base? B. What's my exponent? And what's my y? What is x? 0. Anything raised to the 0 is 1. Okay. Anything raised to the 0 power is 1. If x was 1, what would b be? If I had b to the first, this would be b. Okay. All right, number 7.
You're going to have b.
What's my base? What's my exponent?
B.
X equals b. So this time, what's my x, Riesel? 1. Okay. All right. That leads us to the next set of problems. Now, this is where my last class just completely just started whining and complaining. Okay?
Why?
Okay. Number 8.
base and then 81.
Okay, so I have base 3, my base. Now, what's my exponent? What's this equal to? X. So what's my exponent? What does it equal? 81. Now, this time it says to evaluate it, so 3 to the what equals 81? What does X equal?
27.
No, fuck you, mathematics.
Okay, so 3 to the 4th is 81. So what does X equal? 4. Okay. You're asking yourself, 3 to the what equals 81? So it is 4, but if you did, I mean, even if you had just terrible times with multiplication in your times table, all you have to do is what? Well, you got 3 there. You got to decide how many times you're going to multiply it by itself, right, to get 81. So if I multiply it by itself, well, there's 2 3s. That's 9. So I got 2 3s. Then I got to times it by another 3. That's 3 3s. Then I got to times it by another 3. Here's my 81. So X equals 4. Okay? Easy as that. All right, number 9. I'm just making sure here. Number 9, what's my base?
5.
And again, what's my exponent? X.
And 0.04.
And what is 0.04 as a fraction? 4 over 100. Can you reduce that? How about 1/25? Now, well, you could, but it's harder to figure out what your exponent is, right? Okay, so remember what I said less than 5 minutes ago. Try to think back 5 minutes. Okay?
Yeah, it's been longer.
5 to the what is going to give me 1/25. Huh? So, that's so close. Don't just shout out answers. Do some educated guessing here. What'd you say? 5? Not quite. 5 to the what is going... Okay, look. How about this? Negative what? What'd you say? -2. -2. X equals -2. 5 to the -2 gives me 1/25. Well, first of all, let's ignore this fraction. How do I get 5 to be 25? 5 times 5, which is 5 squared. Okay, 5 squared is 25. Well, now I have to get it in a denominator fraction, so what do I have to do to that too? Make it a negative. So 5 to the -2 equals 1/25. I lost it, right? Okay. Number 10. Guys, knock it off. What's my base? What's my exponent? And what's my y? Okay, let's ignore the fraction for now. 2 to the what is going to give me 8? Third, 3. 2 times 2 times 2. Okay, so my x has to be 3. But here, my 2 is in the denominator. Here, my base 2 is in the numerator, right? 2 to the 3rd. So how am I going to go from denominator to numerator? Minus it. Okay?
Question.
Yes.
How do you put
X equals negative 3.
9
Guys, I can't hear students when you guys are talking loud. As much as I love the idea of tasing, I really love that idea. I just can't do it.
That was
Divide what? Divide what? Oh, well, we're going to look at that. Okay, so number 11. What's my base? 9 to the what equals my solution 3. Shh. Okay, so how do I get from 9 to 3? Is there a relationship between 9 and 3?
3 times
They go into each other. What'd you say? So 3 what is 9? 3 squared is 9. How do I get rid of the power of 2? Square root both sides, right? That gives me my 3. So I just made my 9 a 3, right? You see that? 3 equals the square root of 9. What's another way to write the square root of 9?
3.
Yeah, how about another way? How do I write? How do I write the square root of 9 in another way? In other words, this is radical form. What's exponent form for this? What's exponent form for square root of 9? How about 9 raised to the 1/2? Okay. This is exponential form. This is radical form. We covered that, I think, last semester. So what's my x?
No. 5.
Here I got 9 equals 3. What's my x?
1/2.
1/2. Okay. And again, I was yelling and screaming at my first hour because you should recognize this. And if you did your homework, this would become muscle memory, just like your times tables, and you would know this.
That is.
Oh my goodness. It's just like in grade school, didn't you learn times tables before they put a calculator in your hand? Yeah. So you should learn it this way before you put the calculator in your hand. All right. One more thing to talk about. We have, like an exponent, if I have any number to the first power, we don't, any number to the first power, like 2 to the first, or just, we don't normally put the 1 there, right? We just put 2. It's the same thing with our common log, okay? We have log base 10 to the x. The 10 is called the common log. It's like that first power of an exponent, okay? We don't normally put it in there. So when you see log of x, that's our common log. That really means log base 10 of x, okay? These are the same. Question. Yeah, yeah, but it's going to be a while. Okay. Now, yes. Yeah, you can't. But you can actually put years. Years. I think you gotta. Yeah, years. There is a way to bring up log, but I'm not going to tell you and show you until you learn this. No, I'm not. I'm not. No, no. Okay. Natural log. It's just differentiates something from something else. Okay, now, yesterday, when you did your homework, we did some continuously compounded problems, right?
No.
And you learned a new number. What was that number? E, right? E. E, I told you, was just a natural number found on planet Earth and in physics and space and all kinds of things. Now, hey, log base E of x is what we call our natural log, or ln of x. When you see ln of x, again, we don't normally put the base E in there because you know it's E because of the ln. Okay? See how there's a log base E of x? If you just write ln of x, you don't need to put in the E for the base. All right. Are you ready, kids? We have 4 problems left to do. Now, I tell you what, guys, in your calculators, all right, so you have 2 buttons here in your calculators. You have the log key and you have the ln key, right? What's the base for your log key? And there's nothing there for the base, so what is it? Base 10, right? The common log. So you have the common log key, you have the common log key, and you have the natural log key. Now, if you have anything else, like say the ones we were doing up here, where we had log base 1/2, 2, guess what? You cannot put that in your calculators because you only have common log and natural log. So that's why I made you guys learn it this way. Yes, I am. Okay, number 12. Okay, so I'm going to put an X there. We're going to change this to exponent form, right? Exponential form. What's my base? What's my base? 10. Because there's no base there, it has to be common log 10. What's my exponent? Now, if you want to try to figure out what X is, good luck. There is one, I just don't know what it is. Okay, 13. What's my base? 10x equals 21. How about number 14? What's my base? E. Okay, what's my exponent? And what's my y? 1/10 or 0.1. Okay, what about the finale here? E to the x equals 2. Thank you. Now, we're going to stop there. Okay? Your homework. Your homework. You can do numbers 12, 16, 20, 22, 24, and 28. Comprendes? You can do problems 12, 16, 19, 22, 24, and 28. You should get this done before you leave today. No, it won't. Well, maybe you, because you're so far behind and you don't feel like doing anything.